I mean, from our perspective, we rely on ground station antennas for our teleport operations. In terms of the traditional pedestal-based mechanically steered antenna or dish, parabolic dish, we haven't really noticed a tremendous amount of advancements in those products in the marketplace. I'd say those companies that are thinking about innovating in terms of their antenna control units, in the ways and differentiating themselves in terms of the ways that you command and control a ground station remotely, would add the most value by embracing virtualization of that technology and or the ability to virtualize, meaning modernizing the interface between a customer or a user and the antenna control unit itself, whether that be through a modern application programming interface or API, using advanced or more modern approaches to cloud compute, et cetera. So we're working with an antenna manufacturer now to embed some of our software capabilities into their deliverables that would cloud enable an antenna out of the box, so to speak. So things of that nature add the most value. We haven't seen any companies come to market with an affordable, I would say, complementary capability in electronically steered arrays or antenna products to service our segment of the industry, which is satellite command and control and data downlink and distribution. A lot of advancements in user terminal technology for that purpose, for obvious reasons, but very little in terms of satellite TT&C and sort of ground station as a service, or even gateways or content delivery and things of that nature. Satellite communications. Yeah, and so I think phased array, or I would even go so far as to say multi-satellite link technology, I think, will become important as those constellations, start proliferating LEO. Additionally, I think they'll be important for, I would say, multi-orbit communication transport requirements articulated by the Department of Defense, U.S. government on the whole. The reason being is, these starting with the commercial satellite broadband relay approach, to the extent that those businesses become viable, they'll need to modernize gateway operations on the ground as the satellite technology advances over time. Right, the mission duration for a low Earth orbiting communication satellite, is on the order of 5 to 8 years if they're lucky. So the continuous modernization of the space architecture or space-based infrastructure, if you will, needs to not make the gateway network upon which you rely to execute your business obsolete. Right? So in addition to that, there's only the current approach to gateway operations for LEO broadband SATCOM requires a tremendous amount of real estate on the ground, and I laugh because we're in the middle of potentially building some gateways for one of the major companies in that sector, and it can become very expensive and horribly inefficient, right? As the services provided by the satellite infrastructure scales and grows over time. So there's a tremendous amount of value in multi-beam technology, significantly reducing that footprint on the ground, as well as the supporting infrastructure for that footprint. You begin to open up a lot more possibilities in terms of where you can place a gateway to service these multi-orbit constellations. If that makes sense. It's difficult to say because I'm not in that market. Like I say, Atlas Space Operations primarily relies on satellite ground stations for TT&C and space-based payload data downlink. I think the biggest impact is, as I've stated, in terms of gateway stations and modernization of gateway operations. The impact, I think, would be in the cost to maintain and operate a globally distributed network of gateway stations or teleports. Could have an impact on how current teleport operators approach the future of the business, just in terms of the way that they operate, there may need to be an evolution of understanding on how to manage and control many beams on a single system or antenna. In terms of the flat panel or ESA market is primarily targeting mobility markets for their value, right? So to the extent that you can manage, control multiple beams from heterogeneous space networks on a single aperture, and there could be a big impact there just in terms of the bandwidth available on those apertures, or the expense of consuming that bandwidth. You need to modernize modem technology to be able to handle the potential for higher data rates, I suppose. And if you want to try to virtualize that, then I think the advances really need to consider where you're using those devices, if it is a device indeed, or if it's software defined and cloud hosted. And now you've got the problem of making sure you have sufficient connectivity to manage the transport of the data, going into and coming out of those devices. So it's really it's more of a backhaul problem in my experience than it is I would say an outright capability problem in terms of the hardware, physical hardware. So, for example, if you've got a V-band terminal in a remote area and you need to get that data from the remote area, into the cloud, and that's where your modem is hosted, for example, then you need a tremendous backhaul capability from that remote site into the cloud so you can process the raw IF. But I don't know. I'm not. We're not focused on at this point in time. In my business and for Atlas Space Operations, we don't have any demand signal from our customer base in the foreseeable future for W and V band technology. We're more focused in the S, X, and Ka in terms of radio frequency spectrum that our customers use. I don't think it's a technology problem. I think it's a regulatory problem. I don't know that any amount of technological innovation can necessarily Well, that's not true. We have some intellectual property surrounding how we handle digital beamforming coming off of an array of antennas, whether it be an ESA or distributed nodes of RF panels that we prototyped for the U.S. Air Force. So there are, I think, opportunities for advancing how you manage and your beams coming off of electronically steered arrays, or even arrays of smaller apertures that could potentially help mitigate interference problems. I'm not going to go into the technical details of how we do that, but we have seen our ability to isolate without factoring in the interference present nearby, right? So we've been able to use compressed sensing technology as a part of our digital beamforming algorithms to a certain degree ignore, if you will, through processing, interference present. At certain power levels, that becomes a physics problem, but I think largely it's more of a regulatory issue than a technology issue.